Hello students, welcome to a series of additional mathematics program for grades 10 and 11. The topic for today is differentiation of logarithmic and exponential functions. So let us start. In today's lesson, you will learn how to find the derivatives of logarithmic functions and exponential functions. The prior knowledge for today's lesson, you will need to remember how to differentiate given functions, how to use the product rule, the quotient rule. You will also need to remember the chapter logarithmic and exponential functions, the different laws of logarithm which you have learned in this chapter, and how to find the value of a derivative at a given point. So, let us start with differentiation of logarithmic functions. If I have to differentiate ln x, that is d by dx of ln x, I will obtain 1 over x. Whenever you differentiate ln x, you get 1 over x. If you have to differentiate ln ax plus b, you will have 1 over the function here, ax plus b, 1 over ax plus b, times the derivative of the bracket, that is, times the differentiation of ax plus b. And if I differentiate ax plus b, I will get a. So, differentiation of ln ax plus b will give me a over ax plus b. In general, if you differentiate ln f of x, you will have 1 over f of x times the derivative of f of x. That is, here I will get f dash of x over f of x. Now we are going to look at some examples. Example 1. Find the derivative of the following. So we have 5 parts. Let us look at the solution for the different parts. Part A, differentiation of ln 2x. So it's going to be 1 over the function, 1 over 2x, times the derivative of 2x, which is 2. Simplifying this, I will obtain 1 over x. So differentiation of ln 2x is 1 over x. Part B, differentiation of ln 3x plus 2 will give me 1 over the function, that is 1 over 3x plus 2, times the derivative of the bracket, that is times the derivative of 3x plus 2, which is 3. So, I get 3 over 3x plus 2. Here you need to be cautious. You cannot cancel the 3 in the numerator with the 3 in the expression 3x plus 2. In part A, I was able to cancel the 2 with the denominator here. But here I cannot do so because I have 3x plus 2. I do not have only 3x. So the final answer will be 3 over 3x plus 2. Part C, differentiation of ln 4x minus 1 will give me 1 over the function times the derivative of the bracket, that is 1 over 4x minus 1 times 4, which gives me 4 over 4x minus 1. Part D, differentiation of ln 5 minus 6x will give me 1 over 5 minus 6x times the derivative of the bracket, which is minus 6 here. So the answer will be minus 6 over 5 minus 6x. Part E, I need to find the derivative of ln 3 minus 2x to the square. So here, what I have done, let y be equal to the given expression to be differentiated. Let y be equal to ln 3 minus 2x to the square. Now, you will recall In the laws of logarithm, you have learned that ln x to the power of r is also written as r ln x. So here I will get y equal to 2 the power 2. I put it in front. So y equal to 2 ln 3 minus 2x. Now differentiating, I will get 2 over the function times the derivative of the bracket. And differentiating the bracket will give me minus 2. So dy by dx will be minus 4 over 3 minus 2x. Second example, sketch the curve y equal to ln 2 minus x for x less than 2. Find, first part, the equation of the tangent at the point where x equal to 0. Second part, the coordinates of the point where the tangent meets the y-axis. So, the solution, I need to sketch the curve here. I need to sketch the curve. So, first I need to find where the curve cuts the x-axis. When the curve cuts the x-axis, this means that y will be equal to 0. That is ln 2 minus x equal to 0. This will give me 2 minus x equal to ln inverse of 0, which is 1. And solving this equation 2 minus x equal to 1, I get x equal to 1. So the curve will cut the x-axis at 1, 0. Now, when x equal to 0, I need to find the value of y, which is ln 2. This will give me the y-intercept. So what I have done, I have found where the curve cuts the x-axis and where the curve cuts the y-axis. This will be the curve y equal to ln 2 minus x. So it cuts the x-axis at 1, 0, the y-axis at 0 ln 2. Now I need to find dy by dx. So dy by dx will be equal to 1 over the function times the derivative of the bracket, which is minus 1. Dy by dx will therefore be equal to minus 1 over 2 minus x. When x equal to 0 now, y will be equal to ln 2 and dy by dx will be equal to minus half. To find the equation of the tangent, as you have learned in the previous lesson, y minus y1 over x minus x1 equal to m. So I will get y minus ln 2 over x minus 0 equal to minus half. Cross multiplying, expanding the brackets, and simplifying will give me the equation of the tangent as 2y plus x equal to 2 ln 2. Second part now, this is the equation of the tangent and I need to find where the tangent meets the y-axis. So when the tangent meets the y-axis, x is equal to 0. I replace x by 0 in the equation of the tangent. I get 2y equal to 2 ln 2 and y equal to ln 2. So the coordinates where the tangent meets the y-axis will be 0 ln 2. A third example, given that y equal to ln 3x squared plus 2 over x squared plus 1, find the value of dy by dx when x equal to 2, giving you answer as a plus b ln 14, where a and b are fractions in their simplest form. So here, y is equal to ln 3x squared plus 2 over x squared plus 1. I am going to use the quotient rule which is usually used when we have functions as y equal to u over v, and u and v are functions of x. So let u be equal to ln 3x squared plus 2. Du by dx will be 1 over the function times the derivative of the bracket, that is du by dx equal to 6x over 3x squared plus 2. Let v be equal to the denominator, x squared plus 1. dv by dx will be equal to 2x. Using the quotient rule, which is dy by dx equal to v du by dx minus u dv by dx over v squared. So I'm going to replace all these in the formula to obtain dy by dx equal to x squared plus 1 times 6x over 3x squared plus 2 minus ln of 3x squared plus 2 times 2x over x squared plus 1 to the square. What I have done here is I have written the first part over the denominator. So x squared plus 1 will cancel with the denominator here, and I will be left with x squared plus 1 only. So finally I get 6x over x squared plus 1 into 3x squared plus 2 minus the second term over the denominator. That is minus 2x ln 3x squared plus 2 over x squared plus 1 to the square. So this is the expression for dy by dx, and I need to find the value of dy by dx when x equal to 2. So replacing x equal to 2 in the above expression, I will obtain 6 over 35 minus 4 ln 14 over 25. So what I have done, I replace the x in the given expression by 2. And I simplify to get 6 over 35 minus 4 ln 14 over 25. And we were asked to write dy by dx in this form, a plus b ln 14. So comparing my answer to a plus b ln 14, I will get a equal to 6 over 35 and b will be equal to minus 4 over 25. We now move on to differentiation of exponential functions. So whenever you differentiate e power x, you get e power x. If you differentiate e power ax plus b, you will get e to the power of ax plus b times the derivative of the power, that is, times the derivative of ax plus b, which is a. So finally, you get a into e to the power of ax plus b. In general, if you have to differentiate e to the power of f of x, you get e to the power of f of x times the derivative of f of x, that is f dash of x times e to the power of f of x. Let us look at this example. Differentiate the following with respect to x. Part A, differentiate e to the power of 2x. So I get e to the power of 2x times the derivative of the power, that is, times the differentiation of 2x, which is 2. So I get 2 e power 2x. Part B, differentiate e power 4x plus 5. So I get e to the power of 4x plus 5 times the derivative of the power, which is 4. So the answer will be 4 e to the power of 4x plus 5. Part C, differentiate e to the power of x minus 2 will give me e to the power of x minus 2 times the derivative of the power, which is 1. So the answer is e to the power of x minus 2. Part D, differentiate e to the power of minus x will give me e to the power of minus x times the derivative of the power. That is, I need to differentiate minus x, which is minus 1. So the answer will be minus e to the power of minus x. Part E now, differentiate e to the power of 2 minus 4x. So I will get e to the power of 2 minus 4x times the derivative, that is the derivative of the power, which is minus 4. I will get minus 4 times e to the power of 2 minus 4x. Part F, I need to find the derivative of 5 e to the power of 3 minus 5x. So this 5 is a constant. I can keep it here. I will get 5 e to the power of 3 minus 5x times the derivative of the power. And when I differentiate this, I get minus 5. This will give me 5 times minus 5, that is minus 25, e to the power of 3 minus 5x. Next example, find the gradient of the curve y equal to x, e power x minus 3 at the point 3, 3. So I need to find dy by dx. Here we have two terms, the product of two terms, and I'm going to use the product rule. Let y be equal to x, so I get du by dx equal to 1. Let v be equal to e power x minus 3, and dv by dx will be e to the power of x minus 3 times the derivative of the power, which is 1. So dv by dx will give me e to the power of x minus 3. Using the product rule, that is dy by dx equal to u dv by dx plus v du by dx. So replacing all these in the formula will give me dy by dx equal to x e to the power of x minus 3 plus 1 times e to the power of x minus 3. So factorizing, I take e to the power of x minus 3 outside, and I will be left with x plus 1 in between the brackets. So finally, dy by dx will be equal to e to the power of x minus 3 into x plus 1. I need to find the gradient at the point 3, 3. That is, I'm going to replace x by 3 in dy by dx. And this will give me 4. So the gradient is going to be 4 at the point 3, 3. You now have some exercises to practice on differentiation of logarithmic functions and exponential functions. In question 1 and question 2, you might have to use the product rule or the quotient rule as well. Number 3, you're given y equal to ln x over x cubed, and you need to show that dy by dx is equal to 1 minus 3 ln x over x power 4. Number 4, y equal to x cubed ln 2x plus 1. So here you need to find the value of dy by dx when x equal to 0.3. Number 5, first part, you need to find dy by dx, and second part, you need to find the coordinates of the stationary point on the curve. That is, you need to equate dy by dx to 0. You have a few more questions, number 6, 7, and 8, on differentiation of exponential and logarithmic functions. You also have a few interesting links on how to differentiate exponential and logarithmic functions, and where you can get additional information, and a few more exercises as well to practice. So students, in today's lesson, we have learned how to differentiate logarithmic and exponential functions. A quick recap on what we have done. So when you differentiate ln x, you get 1 over x. When you differentiate ln ax plus b, you get a over ax plus b. And in general, if you have to differentiate ln f of x, you will have 1 over f of x times the derivative of the bracket, which will finally give you f dash of x over f of x. For exponential functions, when you differentiate e power x, you get e power x. If you differentiate e power ax plus b, you will have e power ax plus b times the derivative of the power, which is a. So in general, if you differentiate e power f of x, you get e power f of x times the derivative of the power, that is f dash of x. So students, we have reached the end of today's lesson on differentiation of logarithmic and exponential functions. I would advise you to work out the questions found in your textbook as well to get additional practice. So until we meet again, it's goodbye from me.